All right, guys. So for this lecture, we're going to take a little bit of a look at the last few formed elements. So we're going to finish up with our white blood cells, which would be the majority of this lecture, and then our platelets. We talked a little bit about red blood cells, which are the other formed element, the kind of living portion of blood. But these are going to kind of finish up the rest of them. Okay. So we're going to talk a little bit about white blood cells to kind of start off with here. The typical white blood cell usually is referred to as a leukocyte. Um, and our white blood cells are really important because they're the ones that kind of form that defense for us. They're the ones that form antibodies. They're the ones that go out and attack foreign material that comes into the body, viruses, bacteria, and whatnot. And that's really why they're most important. We usually don't see them in as great of a number as red blood cells because they're really only are there in response to either damaged tissue, tissue that doesn't belong to the body, or foreign invaders that would get into the body like viruses and bacteria. Um, these guys are complete cells. They have both nucleuses as well as organelles inside of them, unlike the red blood cells, which essentially are just sacs of hemoglobin. These guys are also able to move in and out of blood vessels. This process is what's referred to as diapedesis. Okay, so they can actually cross cell membranes. They can also move in and out of tissues. And for the most part, they do this through a process called amoeboid motion, which they just kind of inch themselves along. So sort of think like a worm moving across the ground. That's kind of the same basic process here. Um, they can specifically respond to chemicals that are released by damaged tissue. So if you were to, say, sprain your ankle or have a heart attack, any of those cells that have died during those two processes will release a chemical and initiate our white blood cells to go out and not only get rid of the damaged tissue, but also start the repair process as well. So they're really important. We need quite a bit of them, but they're not. They don't have the same process as red blood cells. Okay, levels of leukocytes in the blood. So normal levels should be somewhere between 4,000 and 11,000 cells per millimeter. If we end up with some abnormal issues, we can end up with a couple things. So the first one would be anything that's above that number. So this is leukocytosis. All right. So these are individuals that have a white blood cell count of above 11,000. If that happens, we usually would kind of suspect that this person most likely has an ongoing infection, and their body has tried to mount a defense against that infection, or they could have some sort of cancer or some sort of immune response that's causing this. So certain types of arthritis, right, is a immune response. Those people that have that type of arthritis, so there's like psoriatic arthritis, is one of them, is one of the specific ones. And what happens essentially is the immune system is attacking healthy tissue for some reason in those cases. But most often, if a person has a blood level above 11,000, we're looking at an individual who probably has some sort of ongoing infection. The other process of this would be leukopenia. Penia here you can see means to lack. So essentially, these are people that have a low level of leukocytes. This can be caused by a couple different processes. You can see here it's normally caused by some sort of drug. A lot of times, a lot of not over the counter medications. Sorry, a lot of times medications can cause a decrease in white blood cells because they're suppressing the immune system in some cases. Antiviral drugs, anti-rejection drugs for like um, kidney donors or any kind of organ donation. So if a person needs a kidney and it receives one from another person, they'd be put on those kind of anti-rejection drugs, and essentially those drugs suppress the immune system. So we would probably suspect that they're going to have a low level of leukocytes in their system. Also, if somebody has some sort of bone cancer, they could also have this problem because these leukocytes are being formed in the bone marrow, and any kind of bone cancer like leukemia or anything else of that nature could cause this to happen as well. Okay. There are two specific types of leukocytes. So there are what are called granulocytes and agranulocytes. So simply the difference here is granulocytes have these little granules in their cytoplasm. So these are your granulocytes here. You've got your neutrophils, basophils, and eosinophils. The other ones you have are your agranulocytes. They lack that kind of granular appearance in their cytoplasm, and you can see them here. We got our monocytes and lymphocytes. Okay. Um, These two categories, just the big difference again is just the fact that they have these granulocytes and don't have these granulocytes. Okay. So we're going to look at them individually. So we'll take a look at the granulocytes first. The first one we have are our neutrophils. All right, these guys actually have what's referred to as a multi-lobe nucleus. You can see it here. So there's one lobe here, another lobe, and a third lobe. And these guys act as what are referred to as phagocytes or phagocytes. They actually go out and kind of eat specifically infections and kind of bacterial and fungal tissue. They sort of act sort of like the Pac-Man of the body because they go in and try to eat these and kind of get rid of them and destroy them. Um, One of the ways that I kind of remember that these are neutrophils because the shape of this right here to me sort of looks like a lowercase n, and that's kind of important with some of these cells. The picture that was on the last slide I don't think is near as nice about the neutrophils because you can see here it doesn't really look like an n. There's a little bit of an n shape here to it. But this picture here is pretty classic example of neutrophils. I think there's an example actually in your workbook that has this. It's got the dotted cytoplasm, and then it has this kind of lowercase n appearance to it, and those are neutrophils. Again, multi-lobe nucleuses. You can kind of see that there. But these, again, are responsible for fighting off both bacteria and funguses, okay? Acute infections. So if somebody's got something acute going on, we would tend to see more of these in their system. The other ones we have are eosinophils. Okay, these guys are kind of large brick red cytoplasmic granules, so you can see that they stain this really dark red. The other thing to me, one of the ways that I always kind of remembered this is to me, this sort of looks like a lowercase e, kind of turned on its side. I don't know if that helps you or not. That's one of the ways that I always kind of remembered it in school myself. Okay. We normally only see these guys in response to allergic reactions as well as parasitic reactions. So if we take a blood sample of somebody and they've got these large amount of these eosinophils in there, we wonder, do they have some sort of a tapeworm or a flatworm in their system? And then we start to ask those questions. Have they been eating raw fish? Did they have some sort of contact with an organism that could have had that? So people that work in, say, like the animal industry, where they're either slaughtering hogs or cattle, they could run into kind of risk of running into these infections as well. Or are they in an area where they come in contact with something that they are allergic to? Okay, we could tend to see these eosinophils in those cases as well. All right. The other ones we see then are these basophils. These guys are responsible for our histamine reaction in the body, so really our kind of inflammation reaction. Um, they contain a substance called heparin. Heparin is an anticoagulant, so that doesn't allow our blood to clot. And because of that, they will cause or initiate that inflammatory response that we see with both injury as well as an allergic reaction to something. And the main reason that we see the kind of swelling associated with both the initial injury as well as an allergic reaction is because they cause blood vessels to become leaky. So a lot of fluid starts to leak out, specifically plasma starts to leak out of those blood cells and into the surrounding tissue, causing it to swell up. These are most often our rarest form of white blood cells. We, again, really should only see them in response to both inflammation and injury. If we see them in the body in large amounts, we end up worrying that this person has some sort of reaction going on. Similar to the other ones I was kind of talking about, they have a specific shape to them. This one isn't as good, but it still does it. To me, this looks like a lowercase b, so I remember that those are the basophils. All right, so again, you've got the granules and the nucleus, and again, that kind of lowercase b shape there. That reminds me that they are basophils. These are the ones, again, like I was saying, that are in response to an allergic reaction because they cause that fluid to leak out into the tissue surrounding them. So again, I forget the name of this movie that Will Smith was in, but he had this huge allergic reaction to something, and it just caused this kind of overflowing of tissue or fluid into the tissue. And one of the ways to reduce that is Benadryl. Benadryl then is a histamine blocker. It's an antihistamine, right? So it doesn't allow those basophils to kind of interact with the tissue and cause the blood vessels to become leaky. So it reduces that basic process. Okay. All right, we're going to move on then to the agranulocytes. There's only the two, the monocytes and lymphocytes. First up here is the lymphocytes. These guys tend to stay pretty much in our lymph nodes or lymphatic tissue throughout our body. The way that they're identified is the nucleus fills most of the cells. So you can see here's a basophil right next to it, right? You see the granules in the cytoplasm there, and then that kind of B shape, right? And then this is a lymphocyte next to it because the nucleus takes up most of the cell. This is even a better picture because it's all nucleus, very little cytoplasm, right? These guys play an important role in our immune response. All right, so there are actually a couple different types of lymphocytes. I was going to kind of show you this here. We'll click over. Um, so lymphocytes, there we're going to talk this more a little about this when we get to our lymphatic system. But lymphocytes, there are two types. There's B cells and T cells. B cells are kind of our immediate responders. They produce a lot of those antibodies that help us react to specific antigens. And then the T cells are the kind of what we refer to as memory cells in the body. They respond to those antibodies that were being produced by the B cells, but they also remember kind of what is in there. So those are the two basic ones that we kind of see in that process that kind of helps us there. But lymphocytes are specifically in immune response. We only see them in response in activation to that. So I know that the coronavirus is one of the big things right now. So what we're looking for with people that have either been exposed to the coronavirus or have had both doses of the either Pfizer or Moderna vaccination, what we're looking for is people to have these lymphocytes, specifically those T lymphocytes, in response to the coronavirus itself. And what they're actually responding to is the protein that's on the outside of the virus. Our body marks everything with protein. All right. All of those proteins tell us that things are our own. So our blood cells, our red blood cells, have a specific protein on the outside of them that tell them that they are ours. Specifically with blood, there's typing, right, that also does that. Our muscle tissue, bone tissue, skin, nervous tissue, all of those tissues have a specific protein on them that the body recognizes as being ours. If we come in contact with a protein that is not us, these lymphocytes will actually go out and attack it and try to destroy it. They'll mark it, remember what that protein then looks like again, and if we come in contact with it again, we will do the same thing. Any vaccination does that for us. So most of you guys have had vaccinations for things like measles, mumps, rubella. You've also had vaccinations against polio, and you guys were lucky enough to get a vaccination against chickenpox. All of those are viral infections that we can come in contact with, and the body is remembering essentially those proteins that would be on the outside of those viruses. Same thing with the coronavirus here. We're looking for an immune response to that protein, and the current vaccinations are just contain the mRNA that makes the protein. So we're injecting people with that mRNA. The mRNA is then uptake by the ribosomes in the cells, and then it makes the protein that is on the outside of the virus. It's actually not making the virus, it's just making that protein. The body recognizes that that protein doesn't belong to it, sends out these lymphocytes and actually attacks that protein and tries to destroy it. In concert with these guys, the lymphocytes are the monocytes. These are our largest white blood cells. These guys can actually migrate throughout the body. They're one of the best ones for that. So a lot of times we see them all over. They function as these kind of macrophages, or what are called phagocytes. They're eating things. They can actually go out and physically attack bacteria, viruses, and fungus in the body. I'll see if I can't find it. I didn't find it before I started this lecture, but there's a video of a monocyte, a macrophage, actually chasing a piece of bacteria around inside of a cell or inside of a blood vessel, and then finally eventually engulfing it. Okay, these guys are really important in finding chronic infections, so bacterial and virus and fungals that get into our body. A lot of times people that have things like HIV, these kind of long-term viral infections, we tend to see a lot of these monocytes in there because the body, again, is trying to fight off those infections. In the case of HIV, HIV actually hijacks these cells and causes the cell to make more of the virus. That's what a virus actually does. Most viruses contain a piece of mRNA, and that piece of mRNA just tells the cell that they infect to create more of that virus. That's all they really have. And what we're trying to do with the vaccination is to obviously allow the body to initiate or recognize that protein and kill it before it can do that. Okay. All right. Last thing, real quickly, abundance of white blood cells. We talked about this, I think, the other time as we went through kind of the general stuff, but I want to give it to you again. So there's a little mnemonic that we use for this called "Never let monkeys eat bananas." It tells you the number of cells based on how much we should see them in a sample of blood. So again, your neutrophils should be the most abundant. Lymphocytes would be next, all right? But that makes sense. These guys are both fighting off kind of infections. Monocytes are next in line. Those are our large white blood cells. And then the last ones we really should see are the eosinophils. Again, they're only in response to kind of allergic reactions as well as um, kind of big infections from like parasitic worms. And then the basophils are only in response to damage of tissue. So unless this person has got lots of damage going on inside of their body, so say like a diabetic, they shouldn't tend to see too many of these. Again, we should see a lot more of these guys, just kind of our natural immune system kind of floating around. Okay. All right, last thing we're going to talk about with the formed elements then are the platelets. Platelets are actually just little pieces of the multinucleated cells called megakaryocytes. They kind of pinch themselves off and they create these little pieces that then kind of float around inside of the body. Their main purpose is for clotting. So they respond to a chemical that's released by tissue that is damaged, that then causes these platelets to become sticky. All right, and then those platelets will stick at the site of where the chemical is being released, and then they will continue to kind of gather up until they form a seal. All right, and again, we should see about 300,000 of these guys in a sample of blood. If we don't, then we worry if this person has some sort of bleeding disorder. So, say like hemophilia would be the big one. They would tend to see not as many of these guys in here. Just because they wouldn't be able to kind of respond to that. Okay. All right. We're going to go and stop there. If you guys have questions about like viruses and kind of our immune response and things like that, please ask, because that's what's kind of going on in the news right now. So I'd rather try to answer those questions now instead of wait till we get to our lymphatic system, whereas we might not cover it as best or kind of cover that in that time. So please ask questions if you got them. I'll try to bring up some other things and try to post them. The video that was at the beginning of this, I'm going to post that link as part of the notes, so that way you guys can watch that, not have to go through the notes as well. But hopefully that'll kind of answer things for these last little bit of formed elements. There are a couple workbook pages to go with this, and I'll post those in concert with this. So that's 198 and 199. I'll get those kind of posted for you guys, and then hopefully we'll get things going.